Welcome to another episode of Current Insights, a production of RMLD, where we sit down with experts behind the scenes and partners to gain insights on how they work and how they help us deliver reliable, low-cost, non-carbon energy to our customers. Today, we have the pleasure of speaking with Johnny Duong. Johnny Duong is a system engineer at RMLD. He plays a crucial role in ensuring both the reliability and the efficient use of our electrical service system as we support our over 32,000 meters. So, Johnny, good morning.
Good morning, Greg.
Thanks for joining us. And, we always start on these little informal sessions, a little bit about yourself. Who are you? How'd you get to be with RMLD? And just a quick summary of your primary responsibilities.
Sure. Well, thank you for having me on the show. I would say who I am would be a system engineer at RMLD. Some of the primary responsibilities that the engineers have, we are involved in many of the front and back-facing services for our customers in our service territory, which is just a very formal way of saying the engineers have a wide range of responsibilities.
Absolutely.
Yeah, we address any and all inquiries that consumers in our service territory may have surrounding their electric service, from placement of their house service drop to flickering lights, part power, energizing and de-energizing of their new or old service, just to name a few. But we make time to meet with our customers to provide these answers throughout our work week, in person or via a phone call. We do our best to work with the customers within our limitations.
Yep.
And as an engineer, we are also involved in the stocking of many of the main components of our electrical distribution system, such as overhead and underground cables and conductors, transformers, switches, lightning arresters, cutouts, and fuses. And the list goes on.
It's a long list.
It definitely is. But we essentially oversee the technical specification of these components, just to ensure that they adequately fit our system and their intended applications. We often stick with the tried and true pieces, but we do our best to stay up to date with new products, which can solve old problems that we may be having. But to simply summarize that all up, I would have to say, as an engineer for RMLD, our primary responsibility would be to ensure the reliability of our entire electric distribution system.
Perfect. Well, that's good. Reliability being first and foremost. And Johnny, you mentioned dealing with the customers, but in addition to the customers and making the connection from our distribution network into their buildings, homes, businesses, commercial entities, you guys also have the responsibility for managing and designing and maintaining or specifying the maintenance of the actual distribution network. Just kind of walk us through what are some of the key pieces of that distribution network.
So
things that customers might see, and we'll talk in more details here in a few minutes. But
yeah, so we have a lot of. So to maintain our system reliability, I guess some of the key pieces would be that on the consumer side would be transformers.
Yep.
And one of our programs that we have in place, our transformer inspection program that we do conduct annually, where we're essentially checking a large amount of transformers for any signs of imminent failure, any issues that it may have, and schedule them for replacement before
end of life.
Before they fail unexpectedly, essentially.
What's the average life of a transformer, Johnny? Typical range.
If it's perfectly fine, a transformer will keep going for 30-plus years.
30-plus years.
Yeah, but nowadays we're seeing certain transformers are leaking more than normal, so we have to figure out how to stop that leak or go back to the manufacturer to see what's going on. But we try to find those transformers quickly and resolve the problem so they don't become bigger problems later down the line.
These podcasts are heard by a variety of different people, and for the residential customer, describe a transformer that they would see, and then we have some of the industrial and commercial customers. What would a transformer that they would see? What would it look like? I mean, just where would they see it? What color would it be? What is a transformer? Not the engineering, but just What's it look like?
Well, transformers that are on poles would typically be round.
Yep.
They're usually white in color, cylindrical.
Canister kind of thing.
Canister,
Yeah.
essentially. For most underground transformers, we utilize what we call pad-mounted transformers, which it's not very
Big green box.
It's a big green box, and they're mounted to a pad, so it's
Hence-
pretty straightforward.
Pad-mounted transformers.
Yeah, we call it like we see it.
That's good. That's good.
But it is essentially a big green box that sits on the ground, and cables come up into it underground.
So the other, kind of talking about, so transformers is one key piece that whether it's an industrial or consumer, residential customer, at some point along the line, they're connected to one of those, right?
Absolutely.
And part of that part of that connection is whether they're 120 volts or 480 or whatever the voltage might be. But the other key pieces they might see are obviously utility poles, right, or underground conduits, and then obviously the cables. So, when you think about servicing an existing customer or a new customer or a customer that's upgrading, what are some of the key considerations and things that you guys think about from an electrical engineering perspective in terms of planning the service upgrade for electrical system, and how do these upgrades contribute or improve system performance and safety as well as solving the customers? So kind of thinking about things you guys think about.
Yeah. Our first considerations would be how much load is this person trying to connect.
Yep.
As this answer, it will essentially drive the next few dominoes. So we have to look into the capacitor limits of the individual circuit that they are connecting into. On the residential side, we are looking at mostly service main upgrades from 100 to 200 amps, and in certain areas 400 amps. But residentially, anything higher than 400 amps are really special cases, and we take a look at that with more scrutiny.
Yep. 400 amps for a residential home is that's a lot of power.
Yep. Well, we're seeing it more and more with these bigger and bigger homes.
Yep.
So it's not out of the ordinary anymore.
Yeah.
But and we might see them get even larger as the years come by. But each of these upgrades will need to be brought to the engineering team for analysis.
Yep.
We investigate the limits of the existing facilities and make determinations of any required upgrades necessary to provide the reliable power to that customer. These limits include and range from the conductor size, the service length, for voltage drop calculations, electrical code compliance, transformer loading. So if upgrades are necessary for an overhead service, for example, evaluation of the existing physical pole comes into play as well. Yep. We have to ask, is it able to accommodate the upgrades, or will we need to replace it, or will additional poles be required? These are just some of the questions and following considerations we must answer before giving our approval.
Yeah, so it's much more involved than just taking an extension cord or a service cord and plugging it into the wall, right?
Yeah, absolutely.
We've our responsibility, right, and you and the rest of the engineering team, how do we make sure that there's always enough power coming out of that plug? Or in the case of industrial, right, it could be a twist lock, or there are a whole bunch of different plug types, obviously, but most customers are familiar with the simple 110, either 15 or 20 amps.
Right, and to elaborate a little bit more on that, as more of these services are being upgraded and the demand for electricity rises in the coming years, we're just going to have to be more vigilant in monitoring transformer loading to ensure that we keep the reliability up.
So transformers sounds like that's one of the key places that you guys spend a lot of time in terms of doing the analysis. I think you mentioned in passing, poles and pole replacements. Besides aging, right? You put larger transformers on poles or more conductors on poles that might require a pole upgrade, a taller pole, a higher class pole, for example. In terms of cabling, though, you guys probably anticipated cablings aren't really typically the limitation, right? I mean, that's a question, not a statement.
Typically not, but if we're upgrading an old 5 kV area where it has old conductor, where it's number 6 copper or something, and we're looking to increase the voltage.
And, number 6 copper is like a 1/4 inch diameter, just for people to get a sense, maybe roughly, or maybe
it's very, very thin. I would say, yeah, about 1/4 inch.
Yeah. Okay.
So, okay.
Go ahead.
Can I just ask a question?
Yeah.
So do you ever run into like a circumstance where people might do their own electrical work without a permit and kind of overload?
Overload.
Right?
Not typically on
For residential.
We don't typically see an overload where a customer would overload and not have a permit and just do it themselves. It would be very rare if it happened, and typically the culprit would have to pretty much know the electrical system and how to circumvent
Right.
everything.
But I think people do try to install their own like EV chargers and stuff. So I would think that it could get.
Yeah, if they do happen to overload the transformer, the transformer there's a fuse for that transformer. So very much like your house, if it becomes overloaded for any reason, it's going to open, and we'll be called out to the location, and we can see all that data after the fact.
We're going to talk a little bit more about. That's a great question, Julie. We're going to talk a little more about EVs in particular. But one of the things you mentioned, Johnny, was the first thing you guys look at is what's the load that somebody's trying to connect, right? And our our intention as a light plant is to provide whatever power they need, right? And so we have to look and say, what is required. So it sounds like the first thing, we have this thing called the electrical load data sheet. Just talk a little bit about why that's important. You kind of got us off the path, but what important things do you look at, and what do you expect the customers to do when they do a load data sheet form?
Yeah, so the load data sheet is effectively a form that the electrician or the consumer fills out to let us know exactly what they're looking to connect.
Or best estimate, right?
Or their best estimate.
As much as they can, right?
Right. It's usually filled out by an licensed electrician, and they sign off on it so that we know they're not just
estimating.
They're not just
guesstimating.
They're not just throwing out a number without any knowledge. So, and we take that information, and essentially we build our design towards that load that they're looking to connect. If they are putting in something that doesn't require any upgrades, then we pass it right along. But we keep that on the file to let them know, hey, this is what you asked for, and this is what we supplied, and this is what it's built out to be. Should they need a bigger service at that point, then we would have to revisit step one with the load data sheet and move on from there.
When you think about that load data sheet, and we'll talk a little bit later, but just initially, you guys try and design in a buffer, right? In terms of, nobody's perfectly, they don't know what the load is going to be exactly, right? And it changes all the time depending upon what's plugged into it. And, Julie knows this, right? From a residential perspective, right? Am I running all my appliances at the same time, doing dinner at the same time? Kids are playing with video games, somebody's out in the garage doing, buffing the car, whatever it might be. Tinkering, yeah, okay, there you go. But, we try and design some sort of a buffer. So, maybe think about it from a network perspective or maybe a transformer perspective. But, if the load is meant to be, 100 kW, kilowatts, how do we think about that? Do we try and design our system to handle 120, or how do we think about those kind of things, just kind of broadly?
So it really depends on who's applying, whether it's residential or commercial.
Good point.
So that's one of the first things we have to consider.
Good.
In a residential setting, whenever that load data sheet gets filled out, it's typically the total kW that they're filling out is the culmination of everything being turned on. It's not very likely that the AC is going on while the heat's going, if it's electric heat.
Typically not.
Typically not. You're not running the washer, dryer, and everything all at the same time, along with the heater, and so we do see what the total connected load is going to be, and as an engineer, we make the analysis. We do conduct the analysis and using past practice
and real data.
And real data,
Yeah.
we can and typically we actually can see what the consumer load is throughout the day. We will know to plan for what is the best worst case scenario. But in terms of when we size a transformer for that residential customers, because they put down 100 kW, we're not putting in a 100 kVA transformer for them.
Right.
It's not going to be that high.
Well, I think that's part of the analysis you guys do as engineers, right? So you mentioned we specify equipment, et cetera, but part of it goes back to this load data sheet. And, one of the things we do with the meter data, right, it's not just for billing, it's for load estimates and load calculations and transformer loading, et cetera. So those meters have a lot of purposes besides just billing. So that, Julie mentioned a question earlier about EVs as an example. And, most of our, I shouldn't say most, we want our customers to know that we are very supportive. But just talk a little bit about, with the rise, we'll say the increased interest in electric vehicles in our territory, and the continued focus on sustainability and being non-carbon. What kind of things, how, from your perspective, what are we doing at RMLD to support the EV infrastructure, right? And doing so in a way that helps us to keep our rates low and also to be compliant or, green, right, the green energy piece. So, how do you kind of think about that, some of the things that you guys are doing on the engineering side to allow us to support that growth and also maintain reliability?
Yeah, so the adoption of EVs is increasing nationally. So there's no doubt about that.
Yeah.
And the consumer adoption of EVs is no different within the RMLD territory.
Yep, good.
So we are being mindful of these increases, and especially this increase in demand by the usage of these EV charging stations.
Yeah.
Whether they be in home or in public.
Yep.
So, and how they ultimately will impact our system reliability. Currently, I would say the RMLD is typically notified when a residential EV charger is being installed.
Yep. Partially because we have a rebate tied to it, so there's we encourage them to let us know. And
there's typically an incentive
to
do so.
Yep, exactly right.
So whenever these applications are submitted to the RMLD, an engineer will be assigned to assess that application,
Yep.
and it goes through the typical analysis process. Same thing with transformer size, but can it handle it? Can it not?
Always back to load, right?
Always back to the load. So, in terms of what the RMLD has been doing, we're also working with towns to install EV chargers in various places. And we have recently installed a number of EV chargers in the towns of Reading and Wilmington, and we're working on getting chargers installed in North Reading and Lynnfield as well.
So speaking of those chargers, can you give the example? In Reading, we have the new DC fast charger, which is way more powerful than your standard level 2. So for that, obviously you had to do, there's a panel box next to it. So can you just kind of talk us through that process?
Yeah. So the DC fast charger is currently located at the Reading Public Library. It is, I believe, our first DC fast charger on the system. And it requires a lot of, it charges your car a lot faster, which means it requires much more demand in electricity in a shorter period of time. So we had to make plenty of upgrades to on the poles and the transformer size, and there were plenty of other facets behind the scene that we had to put in place to supply that fast charger with reliable power. It definitely is it definitely sucks a lot of power in a very short amount of time. So
sure can.
But it's just some of the things that they're just going. These chargers are just going to come up more frequently.
Yeah. And we're as a team, right? And from the engineering perspective, we're supportive. We're thinking about all those. We've got estimates in terms of number of chargers and number of EVs, et cetera. So those are all part of our, not just the short-term issue of how do I support a customer with a low data sheet as a starting point, but how do we think about the network longer term? So that's great. The other thing that our listeners have heard is this concept of in-territory generation, and solar is one of them, right? Solar on either industrial buildings or commercial buildings or residential buildings. So, from an engineering perspective, just talk about some of the things that you guys think about from solar installation, and just partly to educate our customers, things that we look at, so that when we ask questions, we're doing it from the perspective of reliable, low-cost, non-carbon service.
Yeah. So for most of the solar panel installations so far, they've been residential. Primarily. But we are, I believe, Greg, yourself, we've been trying to look for places to put bigger solar fields or solar systems in, so that we can generate our own power to essentially decrease the demand from our substations, which greatly helps the peak. But just to go back to residential systems, we most of those applications hit the Integrated Resources Department at RMLD, and it gets assigned an engineer to overlook the technical specifications of the system. We basically look over the one line, the connection diagram, to make sure that it's wired correctly, and
because that system's actually feeding power back into the network as opposed to being one way. We're now a bidirectional network, right?
Correct. So we have to make sure that key components are in place, like the AC disconnect is there.
Yes. Safety.
From a safety aspect, and so we're basically overlooking the design of the system. We don't physically do any of the wiring of the solar panels. We leave that to the customer, installer. But we will, before the bidirectional meter gets installed, we do inspect the system before giving that approval to make sure all those key components are actually wired in place.
Yeah. And of course, the electrical inspector also has a role in that whole process as well as you guys.
Oh, absolutely.
Yeah, two other topics that kind of as we wrap up this session. One of them is you guys design the network, right? And you specify the network, et cetera. But there's a group of linemen and technicians, et cetera, that actually do a lot of the work. So just talk a little bit between the grid assets, we call it the grid assets team, the meter team, and the line team. How you work with the engineers and the linemen and the meter team to make all this stuff happen, because it takes hands and feet to get this stuff done.
Yeah, absolutely. As engineers, we work very closely with the linemen to ensure all the projects are built up to industry standards. And the engineers will often come out with the entire design and present the whole project as a whole to the line foreman for input.
Yep, good.
At which point we would discuss and accommodate any insights that they may have, and any issues that may arise. And
team effort. Yeah.
Yep, and move the project forward accordingly. But oftentimes, field conditions may call for a change in the design at one or more pole locations.
Yep.
And the lineman will raise these concerns with the project engineer, such as myself. Yeah. These concerns can be suggestions of a safer approach on how to do something, or any unforeseen physical obstacles that may arise, or from a constructability standpoint. Yeah. So these decisions and approvals on changes to the original design will ultimately fall under the project engineer. But as the engineer, we must be able to comprehend and understand many of the little intricate details and reasoning behind the project process, and be able to pivot to a better option from a constructability standpoint when they do arise. So it's more than just lines on a piece of paper or a CAD drawing.
So you guys have a lot of time in the field, right? You guys are in the field, in front of the computer, right? Talking to customers, talking to vendors, talking to purchasing, right? Yep. Working with the IRD team as well. So
we definitely rely on each other.
Yeah, it's a team effort. Yeah, it's pretty clear it's a team effort. Hey, last question before we get to Julie's going to bring us up with the customer question, but a lot of our service is what we call overhead, so poles and lines, transformers on poles. Tree trimming becomes a real important issue, and we talk about this on occasion. But just talk a little bit from the homeowner's perspective. What's their role and what's our role in terms of thinking about keeping and the importance, right? You maybe take a step. Why is it important to keep trees from growing on lines, and then just quick comment about roles and responsibilities. Just short, quick answer, but why is it important, and what does the customer need to expect?
Sure. So trees have this year alone, trees have caused 36 service interruptions by themselves for the year 2023. So
year to date.
Yeah. Yep, year to date. So they are actually the leading cause of outages, which is why we have a tree trimming program in place where we see where there's overgrowth of trees into our lines.
Yeah. Trees grow.
Yeah,
right?
And we have to keep.
And they don't really know what's in their way, so.
Exactly, I don't think they care.
Yeah.
So we definitely stay on top of that to trim out away from our lines, and essentially try to avoid them falling into our lines as best
for
as
reliability,
we can.
right?
Exactly.
For everybody not just in the house that the tree happens to be in front of, but for everybody. Good point. So customers should keep an eye on it, right? And if they see an issue, they should reach out either to ourselves or the town, or kind of just in a sentence. What role do they play?
So if you have a tree concern, if it's something close to your service or it's overgrowing on a pole, definitely reach out to the Reading Light Control Center. Good. And they will document it, and they will find one of the engineers to take a look at it.
Good.
Well,
we covered a lot of ground, Johnny. Thank you for spending time with us on our podcast series, Current Insights. Julie, I'm going to turn it over to you.
Yeah.
Question of the week.
So the question of the week was actually about homeowner responsibility in terms of tree trimming, but there was a second part to that we didn't address. So thank you to our anonymous customer who asked about tree trimming. So in terms of, they ask, how do you prioritize? So when you're setting a schedule for tree trimming, how do you prioritize some trees over other trees?
Johnny, I'll take that one. I think at the end of the day, our network, Johnny kind of walked through some of the highlights, but our network has what we call primary lines and then secondary lines. And the primary lines are the ones that you see on the major roadways, et cetera. And from those branch the secondary lines. So we tend to focus on making sure that since the primary lines support a lot more customers, they get the first priority for both maintenance and restoration, right, when we have outages. Johnny mentioned that trees are the highest order or the number one cause of outages. And so that's kind of the prioritization. And then as he mentioned, we try and keep our eyes and ears open. Our crews are in the field obviously every day. The engineers are in the field every day. But we still, we cover 51 square miles of territory in Wilmington and Reading and North Reading and Linfield Center. So our customers are the eyes and ears as well. And, we are very respectful of trees. We like trees. But we also want to make sure that trees are not hanging on our lines, both from a reliability perspective and a safety for the public, as well as safety of the line crews when they go out to work on them. So it's trees are an important element for reliability, and customers are part of that solution. So Thank you, Julie.
Yeah, and just a reminder to our listeners, if you have a question for us, you can email us at podcast@rmld.com. You can also just email thoughts, suggestions, what you like about the podcast. So we'd love to hear from you.
Absolutely.
So don't be a stranger.
Don't be a stranger. So for myself, Greg, and Julie, and Johnny on today's episode, we hope you guys had learned something and enjoyed what we basically call wired for reliability, right? The role of an engineer in helping RMLD maintain our network. Thank you.
Thank you.